The concept of land cover change is strictly associated to the temporal dimension. In the past, it was needed to have a rough idea on when a change has happened to clearly identify the period and therefore clearly and precisely identify what kind of images would be good to process. However, now with the availability of artificial intelligence methodologies, we are evolving toward the possibility to inject to the systems short or long time series of images and let the system understand when and where the change happened. We have two parts in a change detection problem. The first one is to identify if a change has occurred in the ground or not. So a change from grassland to asphalt is treated in the very similar or identical way of a change from dayland to water, for example. However, as the technology evolved, the availability of data gave the possibility to approach different kind of applications. For example, recently applications related to climate change are becoming more and more relevant. And dealing with these kind of applications requires the need to deal with very long time series of data, thinking about 30 years of data from the Landsat missions to the Sentinels. And they require the capability to distinguish different kind of changes. Those kind of changes started to happen long time ago, and the capability of analyzing a long-time historical series of data allows to a better understanding of what is the impact of environmental variation, either natural or human induced, and their impact on our lives. Understanding long-term changes has great impact on changing political decision, designing new administrative regulation, increase and improve the capability of better planning, for example, urban expansion, understanding where and how locate people or how to design intervention regulation. Think about, for example, huge events like the pandemic situation we are dealing with right now. It has been said many times that the speed of infection and expansion of the pandemic situation might be related to environmental condition. There is a possible correlation with, for example, local climate, therefore local land cover, and also pollution, and so on and so forth. If we could be able to map these kind of variables, and remote sensing is one of the elements that may help in monitoring this kind of variable, then it could be also possible to design guidelines that could become useful and effective in limiting the effects of other similar events. So analyzing this kind of data at different spatial, spectral, and temporal resolution has a huge relevance and may have great impacts on our understanding of the Earth as an environmental system, including humans as actors, in fact, primary actors, with the goal of taking care of its resources and indirectly, therefore, of ourselves within the Earth environment.